So where we ended, section 5.2, was with example 10 in your notes, right? That's where we ended yesterday. We found the domain for that logarithmic function, right? So if you flip over to the next page, right, in example 11, we have to take that logarithmic expression and we have to condense it as much as possible, okay? Now yesterday, we took two logarithmic expressions and expanded them as much as yesterday. But in example 11, we started going in reverse. You're given an expanded logarithmic expression and you got to condense it as much as possible, okay? So my solution to this is on video. And the link to the video is on OAKS. So your assignment is to watch the video solution to this example, okay? And fill out your notes before doing the homework. That is due Monday night, okay? There's only 4 steps, okay? But I explain each step in the video, okay? All right, so that ends 5.2. And so now we're gonna move on to section 5.3, which has to deal with solving various types of exponential logarithmic equations. Let's do the one. All right, so if you look at your note packet, that's all we got, right? Is one exponential equation, one logarithmic equation after the other, right? And we have to solve these. So just various types of exponential equations and logarithmic equations that need to be solved. And so in the first one, right, example 1, instructions are to solve each of the given equations. So the first one is 4 times e to the 2x is equal to 5. Remember, e is a number, a real number. 2.718 to 3 decimal places, okay? It actually goes on forever, right? But to 3 decimal places, so it's a real number. And so there is some real number we can put in for x here that makes the left-hand side equal to the right-hand side, equal to 5. What is that value of x? Now we're going to be finding the exact solution to these problems, right? And then if you need a decimal approximation, right, you have to find the exact solution first and then calculate the decimal approximation. So on the left-hand side, that's 4 times e to the 2x. So you know division undoes multiplication. So we divide both sides by 4. We have e to the 2x is equal to 4. And now our x is in the exponent. And the the base of our exponential is e, what function is the inverse of the natural exponential function? ln, right? The natural log function. And so one of the properties of the natural log function was that the natural log of e to the x is just x, right? Property 3 or property 4, I can't remember which one. So since the left-hand side equals the right-hand side, we can take the natural log of the left-hand side, and it has to equal the natural log of the right-hand side. So since these are equal, we can make each of the left side and the right-hand side, what goes into the natural log function is called the argument in mathematics, right? So we can make e to the 2x and 5/4 the argument inside the natural log function of both sides. And now, properties of the natural log function. This on the left-hand side is just equal to the exponent 2x. So you can think that ln and the natural log function and the natural exponential function cancel each other or undo each other. And so we're left with 2x on the left is equal to the natural log of 5/4 on the right. And now I'm solving for x. Again, division undoes, so that's 2 times x. Division undoes multiplication. So we divide both sides by 2. And we are left with x is equal to the natural log of 5/4. That's the exact solution. Now, if you need a decimal solution, you'd have to use your calculator. Now, there are 2 other ways we can. Yes, ma'am.
Over 2. Where's that 2 go?
Oh, thank you. Yeah, I dropped the 2 over here. Thank you. Thank you very much. Okay. It pays to look at your notes. Okay. So, using your calculator, right? You take the natural log of 5/4, and then you divide, right? And you hit enter, and you get a decimal number. And you divide it by 2, and that gives you the decimal value for x that makes the left-hand side equal to the right-hand side in our original problem. But this is the exact solution. Now, the numerator, okay, can be written a couple of different ways if you want to. Using the quotient rule for logarithms, you can write the numerator as the natural log of 5 minus the natural log of 4. Can't you? Using the quotient rule for the natural log function. And 5 divided by 4 is exactly equal to 1.25. So you could write the numerator as x equals the natural log of 1.25 divided by 2. Doesn't matter. They all have the same decimal value. Okay. I don't care how you write your answer. Okay. You can write it any of 3 ways in this case. Okay. So that is the exact solution to our original problem. Okay. In B, we have 2 to the x is equal to 10. So there is some real number we can put in for x, so that 2 raised to that power is equal to 10. Okay. Now it's not an integer, okay? Some number, decimals, okay, that you can put in for x and makes the left-hand side equals 10. But we got to write out the exact solution. Can you see what the exact solution would be? Two is the base of the exponential. 10 is the value of the exponential. x is the exponent. What's x equal to? Remember, what are logarithms? They're a fancy way of expressing this exponent, right? Using the base and the value of the exponential, right? So in terms of logarithms, x is equal to
Log base 2 of 10.
log base 2 of 10. Now calculate. Now when I was your age, attending an undergraduate, calculators didn't have base 2 on them, right? I have a calculator that's older than you guys are, and it only has the natural log function on it and log base 10 on it. Okay, so this is the exact solution. And so with your calculators, a lot of them will calculate a logarithm in any base, right? TI-84s now will calculate logarithms in any base. You can type in log base 2 of 10 and it'll give you the decimal value. Okay. If I wanted to get a decimal value, I'd have to get an exact, I'd have to use the natural log function in solving for x. And I'll show you how to do that in the next example, okay? But that's the exact solution. And with today's calculators, you can calculate a logarithm in base 2. You can calculate log base 2 to 10 with your calculator. All right, in C, we have 2 to the x is equal to 7 raised to the 3 plus x power. Okay. So we have an exponential on the left and an exponential on the right. There are different bases. If we could rewrite the two sides so that they have the same base, then once we rewrote them the same base, we could just equate the exponents and solve for x. But we can't. We can't rewrite them with the same base, left and right hand side with the same base. So we got to do something else. So there's some number we can put in for x, in the exponent on the left and the exponent right, so that the left hand side equals the right hand side. What is that number? What's the exact solution? Well, in mathematics, in the sciences, the log function, logarithmic function that gets the most mileage, it's used the most, is the natural log function. So we can take the natural log of both sides, and we have the natural log 2 to the x is equal to the natural log of 7 to the 3 plus x power. Okay. So take natural log of both sides. Now on the left, a natural log of 2 to the x. What can I do with this x? It's the exponent on the number 2. Yeah, bring it down front via the power rule, right? And so I have x times the natural log of 2. And I can do the same thing on the right. This exponent on 7, 3 plus x, I can bring it down in front of the natural log function. So I have x times the natural log of 2 is equal to 3 plus x times the natural log of 7. So here I applied the power rule. Now what you may notice is this is a linear equation in the variable x. I've been solving linear equations in the variable x for a few years now. Okay. The only difference with this linear equation and others you solve is you got real numbers involving the natural log function, right? The natural log of 2 is a real number. It's like 0.69 something. so is the natural log of 7. These are real numbers on the real number line, okay? And if you use your calculator, you can see that natural log 2 has a decimal value, and so does the natural log of 7. So we're going to solve for x in this linear equation like we've always done, okay? Except we got to deal with these numbers involving the natural log function instead of just whole numbers, okay? Integers and fractions. So first thing we're going to do on the right hand side is distribute the natural log of 7 inside the parentheses. So we have x times the natural log of 2 is equal to 3 times the natural log of 7 plus x times the natural log of 7. So we distribute in this step. Now we've got just one term on the left, two terms on the right, and so we want all the terms with x as a factor on the left-hand side, and term without x as a factor on the right-hand side. So we're going to move this x times the natural log of 7 to the left-hand side via subtraction. And so when we do that, we have x times the natural log of 2 minus x times the natural log of 7 is equal to 3 times the natural log of 7. So what we did in this case was subtract. X times the natural log of 7 for both sides. And now you can see we have two terms on the left. Each term has x as a factor, so we can factor out an x then. And so we have x times the natural log of 2 minus the natural log of 7 is equal to 3 times the natural log of 7. So in this step, we factor out an x, dx. So now on the left-hand side, we have x times this in parentheses. What then does multiplication? Division, right? So we just divide both sides what's in parentheses here, and we isolate the x on the left-hand side. Divide both sides by the natural log of 2 minus the natural log of 7. What's in parentheses cancels on the left, and we're left with x is equal to 3 times the natural log of 7 over the natural log of 2 minus the natural log of 7. That is the exact solution to our original problem. Okay? That's what you put in for x over here. That's the exact solution. Now, if you're asked for a decimal answer, this is when you get out your calculator. Calculate the value of the numerator, calculate the value of the denominator, divide the value of the numerator by the denominator value to get your decimal answer. Okay. Any questions on that? Before you write out a decimal value for x, you got to know what the exact solution is. Okay. All right, any questions on that? All right, in D, we have 2 times the natural log of 3x is equal to 4. Now remember, when I told you the natural log function, because it's a special function, right? Sometimes we drop the parentheses. So remember, the natural log of x and ln of x, right, means these are the same thing. We just drop the parentheses. Okay, sometimes we put parentheses around the argument that goes into the natural log function, and sometimes we don't. Okay. All right. So again, now you got to solve for x, right? There's some number we can put in for x that makes the left-hand side equal to the right-hand side. Okay, equal to 4. Well, this is 2 times ln of 3x. So, you know, division undoes multiplication. So we divide both sides by 2, and we have the natural log of 3x is equal to 2. Well, the x is in the argument of the natural log function, right? So to isolate x on the left-hand side, we got to get rid of ln, the natural log. How do we do that?
Multiply by e.
Is it multiply by e? You're close. Remember, what?
Was it divide by?
Divide.
And the e is the natural log.
Yeah, so again, it's, I can't remember if it's property 3 or property 4 for the natural exponent or for the natural log function. But e raised to the natural log of x, right? ln of x is an exponent on the number e, right? So this is e raised to the power ln of x. That's just equal to x. Okay. So since these two guys are equal, we can make them exponents on the number e. So we have e raised to the natural log of 3x is equal to e squared. So we're not multiplying by e, we're not dividing by e, we're making these two numbers exponents on the number e. Okay. Since these two guys in, right, so we got an exponential on the left, exponential on the right. Each exponent has the same base of e, right? So the exponents must be equal, which they are. Well, property 3 or 4, whichever one it is, says the left-hand side just simplifies to 3x. So we have 3 times x is equal to e squared. Now e squared is a real number, because remember e is 2.71 something. So 2.71, this is like 2.71 squared, right? E squared is a real number. So now to solve for x, we divide both sides by 3, and we get x is equal to e squared divided by 3. And so to get your decimal answer, using your calculator, raise the, right, you have an e to the x key on your calculator. You raise e to the second power, divide by 3. There's your decimal answer. All right, on the next page, you might want to draw a line down to the left of the F, right? Just split the page in half so you're not mixing work from one side to the other. In E, we have the natural log of x minus 1 minus the natural log of x minus 3 is equal to 1. So x minus 1 is the argument going into the natural log here, and x minus 3 is the argument going into the natural log here. So we got to find the real number that we can put in for x on the left-hand side that will make the left-hand side equal to 1. Okay. Well, we talked about condensing and expanding. Actually, we talked about expanding. You have to watch the video on condensing. But we have a rule of logarithms. I'll review it with you. Called the quotient rule. And the quotient rule said the log of v, natural log of v, minus the natural log of, actually I think it's the other way around. Natural log of u minus the natural log of v is equal to the natural log of u over v. It's called the quotient rule. I think we did use it, only we did with real numbers in our lecture. So I can rewrite the left-hand side as the natural log of a quotient. The natural log of x minus 1 over x minus 3. Okay. X minus 1 goes in the numerator, x minus 3 goes in the denominator. If I were to expand this, it would be the natural log of x minus 1 minus the natural log of x minus 3. So application of the quotient rule. Our x is in the argument of the natural log function, right? So how do we get rid of the natural log? We just did it. Make the left side and right hand side exponents on the number e, right? So we have e raised to the natural log of x minus 1 over x minus 3 is equal to e to the first power. Right? I can make the left side and the right side exponents on the number e, right? Because now I have exponential left, exponential on the right, same base, so the exponents have to be equal. Well, on the property 3 or property 4, the natural log function, this is just equal to what's in parentheses on the left-hand side. X minus 1 over x minus 3 is just equal to the number e. Remember, this is 2.718. Got division on the left side. What undoes division? Multiplication. Where you multiply both sides by x minus 3, clear the fraction on the left-hand side, right? So we have x minus 3 times x minus 1 over x minus 3 is equal to e times x minus 3. So the x minus 3's cancel on the left, and we're left with x minus 1 is equal to e times quantity x minus 1. And so now we're going to, on the right-hand side, distribute that e inside the parentheses in our solving for x. And we have e times x minus e times 3, which I prefer to write as 3 times e, right? So e times x minus e times 3, which I prefer to write as 3 times e. And now you can see, right, on the left we got one term with x, on the right we have one term with x, and we have a constant on each side. So we need to move the plus and the minus 1 to the right-hand side by addition. And we need to move the e to the x, e times x, excuse me, to the left-hand side by subtraction. So we have x minus e to the x is equal to 1 minus 3e. Oops, oops, oops. It's not e to the x. It's e times x. There's a difference between e times x and e raised to the x power. Right? It's easy to forget that. There's e to the x and there's e times x. They're not the same thing. Okay? So now on the left we can factor out an x. We have x times 1 minus e. X times 1 minus e is equal to 1 minus 3e. And now we can divide both sides by 1 minus e. And we're left with x is equal to 1 minus 3e over 1 minus c. That is the exact solution to our original equation. Okay. Now, if you need a decimal solution, decimal answer, this is where you got to use your calculator. Remember, this is e to the first power here. Okay. Invisible 1 in the exponent. Any questions on that? All right, let's take a look at F. We have the natural log of x minus 2 plus the natural log of 2x minus 3 is equal to 2 times the natural log of x. Well, the first thing we're going to do is condense the left-hand side. Remember the product rule. The natural log of u plus the natural log of v is equal to the natural log of u times v. So this left-hand side is equal to the natural log of x minus 2 times 2x minus 3 via the product rule. And on the right-hand side, this 2 out from the natural log, what can I do with it?
Raise x to the.
Bring it inside the logarithm and make an exponent on the variable x, right? We have natural log of x squared by the power rule. So just to remind you of that, okay, n times the natural log of u is equal to the natural log of u to the n. That is known as the power rule. Now, we have the argument inside the natural log on the left-hand side. Right, we have a natural log by itself on the left-hand side. And we have a natural log by itself on the right-hand side. Right, this is log base C, this is log base C, right? So since we have a log on the left and a log on the right, with the same base, the arguments must be equal, okay? So you could take the number e and raise the number e to this power, and on the right hand side, take the number e and raise it to this power, so that the e and ln cancel, and then you just end up with this argument on the left is equal to that argument on the right. Okay? So the arguments must be equal. And now when I FOIL the left-hand side, I get 2x squared minus 7x plus 6 is equal to x squared. So this is now shaping up to be a quadratic equation, isn't it? We'll move the x squared to the left side by subtraction. 2x squared minus x squared is x squared. So x squared minus 7x plus 6 is equal to 0. This factors x minus 6 times x minus 1. Now apply the zero product property. X minus 6 is equal to 0. X minus 1 is equal to 0. X equals 6. X equals 1. Now, here's the problem. It appears there's two solutions, doesn't it? One of those is called an extraneous solution. 6 and 1 are the solutions to our quadratic equation here. But only one of those numbers work in our original equation. Do you know which one it is? 1 doesn't work because when you put in 1 in for x, you have the natural log of 1 minus 2. 1 minus 2 is equal to negative 1. Can you take the natural log of a negative number? No. Negative numbers are not in the domain. So there's only one solution to our original problem. X equals 1, you have to cross out because it's called an extraneous solution. Okay? You gotta be careful whenever you're solving a quadratic, these types of equations, right? Log equations, so you don't end up with an extraneous solution. Okay? So have a good weekend. Make sure to have some fun this weekend, and I'll see you Monday.